Hello everyone. I hope you're doing good. Thank you for joining us for the third lecture series on actuators. For those who might be joining us for the first time, my name is Dr. Sandrilla. Before we dive into the details, let me outline the purpose of today's lecture. Today, we will embark on a journey to explore the fundamental aspects of actuators. We will discover what they are, how they work, the various types that exist, and their crucial roles in powering an impressive array of systems and devices. And by the end of this lecture, you will have a solid understanding of what is actuators and their significance in modern engineering and technology. So, let me start today's session with a thought provoking question. Have you ever wondered how your smartphone's camera outfocuses so quickly and accurately? Or how a robotic arm in a manufacturing plant precisely picks up and assembles delicate components? Well, the answer lies in the magical realm of actuators, the unsung heroes responsible for converting the electrical signals into tangible motion and force. So let's take a quick look at the agenda for today's lecture so that we know what exciting topics are awaiting for us. So we are going to see what are actuators, understanding the basics and functions. And next, the types of actuators. Here we explore the various mechanisms and their unique characteristics. And the principles of actuation. So here the unraveling the science behind how they transform energy into motion. And finally, the application of actuators. So the witnessing the incredible real world uses in different industries. So before we delve deeper, let's take a moment to understand why actuators are such a crucial part of modern technology. So actuators can be aptly described as the multiples, or it is a muzzle of machines. They are the workhorses that enable our gadgets or the vehicles or the industrial robots and many other systems to carry out specific tasks with precision and efficiency. Okay, so let us start with the introduction, and the definition goes like this. As I told you, actuators are described as a muzzle of machine. These are the devices that make things to move or perform a particular action in response to an input signal. So, what is the major role of this actuators? So, they are the muscles of the system. They are responsible for physically executing the tasks based on the control signals they receive. So, these actuators makes our life very easier. It makes in day-to-day life, everywhere we use these actuators. So this is a functional diagram that has been given. So it has an input signal and the control system. This input signal which commands or controls the signal provided to the actuator. This will specify the desired action or the position. And next comes the control system or the control signal. So this controls the system. It processes the input signal and generates the necessary instructions to drive the actuators actually. And comes to the after giving a control signal, it comes to the actuator mechanism that is called as actuation mechanism, which is called as an heart of the actuator, and this defines how the input signal is converted into motion or force. So this actuation mechanism can be different for various types of actuators, and the final is after converting it, it gives the output motion or the force. So here the final output of the actuator is the motion or force applied to perform a specific task. So this can be done by linear or by the rotational or by pressure, or it based on the application's requirements. So this is the functional diagrammatic representation of actuator. So next comes the types of actuators. So actuators comes in various forms and each type serves a specific purpose depending on the application. Two main categories define actuators. They are the movement and the power source. The how much power that we produce and how it moves. Okay. Actuator movement type, it can be categorized based on their movement type. Either it can be moved in linear or in the rotatory motion. So this linear actuators produce linear motion in a straight line and rotatory actuators produce rotatory motion in a circular path. So this is very important to know that how the actuator actually moves, how it keeps going inside, how it moves. So this is what is a linear actuator. As I told you, it has two types of movements. One is linear actuator and other one is a rotatory, where linear is in a straight line and the rotatory in a circular motion. So linear actuation, as the diagram represents here, the picture, it is the linear actuators which move the objects along a straight line using a belt and pulley rack and pinion or ball screw to convert the electric motion rotation into linear motion. So these actuators are commonly used in food processing, automotive material handling, and more for tasks like pushing, pulling, lifting, and positioning. So this is how the linear actuation looks like. And the next one is the rotatory actuators. So this, as I told you, rotatory actuators move in the type of circular motion where it converts the energy into rotatory motion through a shaft to control equipment speed, position and rotation. So these actuators have a continuous rotational motor and are versatile in usage. So rotatory actuators are used in medical equipments, radar and monitoring systems like in robotics, flight simulators, semiconductor industry, special machine manufacturing and defenses. So these are the two ways how the actuators actually move. So next comes the types of actuators. There are multiple types of actuators. Some actuators that we have defined here is electrical actuators, hydraulic actuators, pneumatic actuators, and mechanical actuators. As I told you, electrical actuators, it converts the electrical signal into mechanical motion. Hydraulic, it is pressurized fluid to create motion, movement. Pneumatic actuators is due to the compressed air which generate the motion, and mechanical which converts the input force, whatever force that we give, that turns into a motion. So the first thing is electrical, by means of electrical. The second means is by means of fluids. Third one is by means of air, and the fourth one is the means of how much pressure or how much force that we give to make the object move, make the things move. Okay, so these are the types of actuators. Let us see deeply one by one. So first comes as the electrical actuators. So imagine you have a magical device that can turn electricity into movement or action. That's what is called as this electrical actuator. It is like a little helper that takes an electrical signal as input and uses it to make things move or perform a specific task. Just think of it as an electric motor that can do different tricks. Okay, so this electric actuator, something works in this way. Like it uses DC motors, it uses AC motors, servo motors, stepper motors, linear motors, piezoelectric actuators, electromagnetic solenoids, electromagnetic relays. In such a way, this electric actuators work. So what is this DC motors? It is nothing but direct current, where the motors are a fundamental type of electrical actuators. Here also it converts the electrical energy into rotational motion. So this might come in various configurations. And next is the AC motors, which is an alternating current. Here also the motors is another type of electrical. Everything is electrical energy which is converting into some rotational motions. Okay. And the servo motors are the specialized type of electrical actuators that offer precise control of angular or in a linear position. They are commonly used in positioning such as robotics, CNC machines, cameras, and everything. And stepper motors are designed to move in discrete steps, making them suitable for applications where precise control of position and speed is required. And next comes the linear motors, which is directly produce linear motion without the need of additional mechanisms. So here they don't, I mean, they use this ball screws or belts as I have given here in the picture. Piezoelectric actuators are nothing but in certain materials to produce motion when subjected to an electric field. In such ways, we use this piezoelectric actuators. And electromagnetic is this is the solenoids. These are very simple electrical actuators that convert the electrical energy to linear motion. And the next one is electromagnetic relays. And here the electrical actuators that control electrical circuits by opening or closing in response to an electrical signal. So this is how this electrical actuators work. The main job is that this electrical actuators are the one which converts the electrical signal as a, I mean, takes the electrical signal as an input and makes the things to move or perform a specific task. So next comes the hydraulic actuators. So here, just imagine a superhero with incredible strength who can push and pull heavy objects effortlessly. That is what is this hydraulic actuators do. Okay, so these hydraulic actuators are just like a super strong muscles of the engineering world. They use the power of fluids. As I told you before, electrical actuators are by electrical energy, and this takes the input as input in the form of fluids or liquids to create movement and perform powerful tasks, something like petrol or diesel or something like that. Okay, so this is a superhero with the incredible strength. So here here's how they work. Here they use the fluid power, the magic pump. Pressure is the key, and they use push and pull, one way street, super versatile. Okay, in this way it works. So when we give a fluid part, hydraulic actuators use a special fluid, usually like oil, that flows through pipes and tubes to transmit the power. So this fluid is like the superhero energy source, and magic pump is the heart of the hydraulic system. It takes in the fluid and pressures it just like the superhero charges up with the energy. And next comes the pressure, which acts as a key. When the fluid becomes pressurized, it gains lot of force. The force is like the superhero strength, really to do work. And next is the push and pull. Here it works something like when a pressurized fluid is sent to a cylinder, here it which is like a hollow tube like piston or inside. When the pressurized fluid pushes the piston, it creates a powerful force that can move heavy objects or other tasks. And the next one is one-way street. Here it controls the movement. There are valves that direct the fluid flow in specific valves. These valves act like traffic controllers, determining whether the fluid should push or pull or stop. All these are done by this one-way street. And the final one is the super versatile. This is also something, an hydraulic actuator, which can be designed to produce linear motions, that is pushing or pulling, or rotatory motions like turning, or making them very versatile for various applications. Okay, so just like how superheroes use their incredible strength to lift cars or move mountains, or hydraulic actuators can handle heavy loads and perform tasks that would be impossible for regular muscles or other actuators. So these hydraulic actuators are commonly used in various industrial applications like heavy machineries, construction equipments, airplane landing gear, because they have a muscle power behind many large and powerful machines, making them essential for getting big jobs done efficiently and effectively. That is why they, in that cases, they use this hydraulic actuators. And the third one is a pneumatic actuator. So here the pneumatic actuator works sorry. The pneumatic actuators are the devices that are used to compress air to create mechanical motion or perform specific tasks. Certainly, when we dive into pneumatic actuators, imagine a superhero who can blow a powerful gust of air, as when we see in the previous slide, a superhero with what magical what is that fluid, magical power. Here, imagine a superhero who can blow a powerful gust of air and move objects with the force of the wind. Well, that is called as pneumatic actuators. Here how it works similarly, using compressed air to create movement and perform tasks. So how do they actually work? They work with compressed air power, the air pump, pressurized energy, air in the chamber, moving with air, controlled airflow, simple and efficient. Okay, when we give a compressed air power, pneumatic actuators use compressed air, which is like the superhero special ability to blow strong gusts. This air pump is a compressor which acts as a heart of this pneumatic system. It takes in the air from the surrounding and compresses it and charges up with the air power. And pressurized energy, when the air is compressed, it becomes filled in with energy like a balloon ready to burst. This pressurized air is now full of force and ready to work. So initially it takes the air inside, and then in the heart, that is in the air pump, it surrounds the air completely, and then pressurized energy, it makes us like balloon ready to burst. It keeps the energy in such a way, it fills the energy, it is compressed there, and then in the fourth stage, air is pushed into the chambers. The pressurized air is directed into the chambers like a cylinder where it can push or pull something, and then it comes to moving with air inside the chamber. There is a piston that's like the superhero's hand. When the pressurized air pushes or pulls the piston, it creates movement and force. And then it comes to the controlled airflow, where here it controls the movement. There are valves that regulate the airflow. So whether it has to give a strong force or a light force. So this controls the strength of the gusts. And finally, it makes it very simple and efficient using these pneumatic actuators, which are known for their simplicity and efficiency. They can perform tasks quickly and as well as easy to control. Okay, so just like how a superhero can move objects with their powerful breath, pneumatic actuators can handle various tasks using compressed air. They are especially useful for applications that require rapid and straightforward motions or the movements, and they are commonly used in industrial automation, manufacturing processes, and in everyday things like drills, air powered tools. They provide a cost effective and reliable solution for many tasks that require a good balance of strength and speed. Okay, there are types of pneumatic actuators. Here it comes like this. They are linear and rotatory. Okay, so this works only in a linear motion, and this is an example. This picture is an example for the rotatory, that is in a circular motion. It works. The air pressure is pressurized in a circular motion, whereas here it is done in a linear motion. So this can be done in a single acting pneumatic actuators, or in a double way also it works. So next comes the magnetic actuator. So the magnetic actuators use magnetic fields to create motion or force. They rely on the interaction between magnetic components to produce mechanical movements. So they use three types of magnetic actuators. One is electromagnetic actuator, voice coil actuators, magnetic levitation actuators. We'll see one by one how these magnetic actuators work. So these actuators consist of an electromagnet, which is a coil of wire that generates a magnetic field when an electric current passes through it. And the next is voice coil actuator. Here it has a type of electromagnetic actuator used to produce precise and linear motion. And the third one is magnetic levitation actuator. This uses or utilizes a magnetic field to levitate an object without physical contact. And the next one is a thermal actuator. The thermal actuators use the principle of thermal expansion or contraction to produce mechanical motion. So when a material is heated or cooled, that is what we called as a thermal, something which is heated or something which is cool. So this undergoes the dimensional changes which can be harnessed to create movement of force. When it is more heated, it makes a movement, or when it is more cooled, it makes a movement, or it acts as a force. There are various types of thermal actuators. One is bimetallic actuator, SMA, which is called the shape memory alloy actuators, and the thermal bimorph actuators. Let us see what is that. Bimetallic is of two different metals bonded together. As the temperature changes, if it is hot or cold, according to that, it expands or contracts at a different rate, okay, causing the actuator to bend or to move. So they use this in the industries to bend something or to move a strong rod or a string. They use this. So SMA actuators are made for special alloys that have the property of shape memory. So when heated above a specific temperature, this SMA material undergo a phase transformation and returns to a predefined shape. So this they use it in cutting of glasses or melting of glasses or making some material or things using glasses or something like that. So they give the shape which can use to create motion. And thermal bimorphic actuators, this consists of two different layers with different coefficient of thermal expansion. So when heated, one layer expands more than the other, causing the actuation to bend or to curve. Okay, so in such ways these actuators are used, thermal actuators. So both the magnetic and as well as the thermal actuators have the unique advantages and limitations. And these magnetic actuators are often preferred to their precise control and fast response times, because as we know, magnet, it attracts it fast. While thermal actuators, it is simple and self-sustainability, where how much ever it is heated or how to the level of its coolness, it attracts. Okay, so that is the difference between the thermal and the magnetic actuators. And the last one is the mechanical actuators. So mechanical, when we talk about this mechanical actuators, imagine you have a special device that can move things or do tasks using only mechanical parts and no electricity or no air. That's what is a mechanical actuator is. It's like having a little helper that uses gas or levers or screws to create movement and forces. So here's how it works. So how it works, it has been given here. It works with the screw jaw, rack and pinion, cam mechanisms, toggle mechanisms, lever, crankshafts and connecting rods, and finally levers and linkages. So this is how it works. So when it comes to the screw jack, imagine a big screw that you turn with your hand. When you twist it, it moves up or down. But pushing or pulling something along with it, it goes easily, okay, in that way. And rack or pinion, picture a gear meshing with this long flat bar with teeth. When you spin the gear, the bar moves back and forth, make something slide with it, okay. And cam mechanism, rotating the shape with an uneven space, or turning it or pushing it or pulling it in a part connected to it, it moves in a specific pattern. And toggle is picture two bars connected by a hinge. When you move one bar, the other moves too. So in such ways, we use the pulling and pushing effect. So that is what is called as toggle mechanism. And levers and linkages, crankshafts and connecting rods. Picture the spinning part of an engine. They convert the up and down motion of the engine's piston into a rotation that makes a car's wheel move. Okay, in that way it works. And levers is when you push down on one end, the other end goes up, and you can use this motion to do like cutting with scissors or gripping with pillars. Okay, in such way this works. So these mechanical actuators are like magic machines that use basic mechanical principles to make things move or work. They are often found in everyday tools, machines and devices, helping us to do many tasks efficiently and without the need for electricity or air pressures. So from simple hand tools to complex machines, now we use this mechanical actuators, which plays a crucial role in making things happen. Okay, so these are the types of the actuators. So actuators are like movers and shakers of the engineering world, making things come to life and perform tasks. There are various applications in our daily lives and in different industries. So here let's explore a few of them in their basic applications. So they are used in robotics. How they are used in robotics? They are the muzzle for those act as a muzzle for the robots. They help robots move their arm, legs, grippers, allowing them to perform tasks like assembling cars, exploring planets in such a way. And they are used in automotive systems. Here, they are used in a cars to control many functions like opening and closing the windows and doors, adjusting mirrors, and operating power seats in such way in automotive systems. Aerospace actuators control the movement of wings, flaps, and other controlled surfaces, helping the aircraft fly smoothly and safely. In such way, it is used in airspace. And next comes the industrial automation. So industrial automation, it is very essential in factories where they control or conveyor belts, robotic arms and other machines, streamlining productions. When they wanted to do it, they use this actuators to improve the efficiency. And in home appliances, we found in appliances like washing machines, dishwashers, and refrigerators, making them work automatically and save us time and effort. And the sixth one that we use is medical devices. It is playing a major role in medical equipment such as MRI machines, robotic surgical systems, and helping improve healthcare and patient outcomes in such ways. And next is the valves and HVAC systems, where it controls the valves in plumbing and heating systems, ensuring the right flow of water and adjusting the temperature in our homes and buildings. In such ways, these are used. And next is the consumer electronics. Say, for example, in our smartphones and cameras, actuators control features like autofocus, zoom, vibration, something extra like that. And next is the entertainment and gaming. Here it is used in amusement park riders, simulators, gaming controllers, creating immersive experiences for entertainments. In such ways, it is used in the gaming and entertainment. And the last one is space exploration. In space missions, actuators control the movement of spacecraft, components, and scientific instruments, helping us to explore the universe. Altogether, this actuators makes our work more easier and makes it more efficient and simpler. In other words, thank you.